In this nugget, we will look at some more CLI commands. Image prune. This command is used to remove unused images. If used without any further option, it removes the dangling images only. Let's go to our Docker host and do docker image ls first. So there is one dangling image that we have to remove on this host. So let's say docker image prune. It asks for the confirmation, say yes. Okay, so it says it is now done and it has reclaimed around 83 MB of space. If I do docker image ls again, I see the dangling image deleted now, so we don't have it. If used with the option --all or just -a, then it removes all the unused images, not just dangling ones. So docker image prune, so let's go back to the host and say docker image prune -all. It asks for confirmation, say yes. It has deleted quite a few. If we do docker image ls, it will show the Redis image which has the container using the image. If we need to display detailed information on one or more images, we need to use the docker image inspect command. Okay, so let's use the let's get back here. Docker image ls, docker image inspect image id. We get quite a lot of information about this particular image, so let's move it. We can further format the output using the format or -f command. Okay, so that also can be done. Now an existing image on the local Docker host can be tagged as a new image also. In this case, the image exists with the old repository name and version, and also with the new repository name and version. The command for this is docker tag. We get the source image colon the tag and target image colon the tag. Let's get back to the host once again. So here we will do docker image ls. So we just have one image. Let's tag a Redis image into a complete repository, say pushpum test latest. So docker image tag Redis latest. We'll be tagging it to pushpum test latest, right? Now if we do a docker ls now, both the images will have the same ID. So one has pushpum test and the other has the Redis one. Similarly, the Redis latest image can also be tagged as another version, say 1.1. So let's try and do that. So docker image tag Redis latest. So instead of that, we'll give Redis colon 1.1. If we do the image ls again, now there are 3 images out here, if you can see. If the same image is tagged multiple times, then the initial first image removing just untags the image. So let's try and do that. Okay, so docker image rm, we'll see pushpum test. Okay, so before going into this, let's remove the container first which is associated with this, otherwise it will error out. So docker rm, the container id, docker rm, the container id. Now let me remove the first image. So we'll again, yeah, ps-a. So as we can see, that is still created. Status is, so docker image rm push pump test and latest. Okay, so if you see, this has just done the untagging because there are multiple images still existing on this system. So if we do docker image ls now, we still have two images. So let's go ahead and remove docker rm redis latest. Okay, so we need it gone, no such. Okay, so yeah, so I forgot the image one. Okay, so this is done. So this is also untagged, only one image is still left. So if I remove that also, let's go ahead and remove that. Docker image rm redis 1.1, it should remove the image also, right? So yeah, so as you can see, it has deleted, actually not untagged. So these are some of the most common CLI commands to be remembered from the exam point of view. In the previous nuggets so far, we have seen listing and handling of images on the local Docker host. This particular section, we will talk about listing and handling of images present on the default registry, which is the Docker Hub. So there are two types of registries. First is user repositories, which contain images contributed by the Docker user. And second is the top level repositories, which are controlled by Docker. User repository takes form of username and repository name, whereas top level repositories only have a repository name, like for example Ubuntu. So now let's get back to the Docker Hub and search for Ubuntu. Okay, the first few are all top level repositories. Okay, so it's this Ubuntu and all these, right? If we scroll a little bit down, we will see the user level repositories as well. So they take the name as username followed by a slash and the repository name. Here are a few of those types of user level repositories. Some of the examples are here: Pivotal Data, then we have the Bassmule, Bash Tools, Ubuntu. See, these are all the following that format which we just follow. Okay, so as we have seen in the earlier sessions, we can pull a specific image from the repository. We need to mention the name of the repository colon followed by the image tag. So let's say I search for Selenium in the Docker Hub. So let's get to the details for the first repository, that is Selenium. Okay, so here the first repository is like Elgalu Selenium. Let's go to the tags, and I want to download the image. Let's go to the tags first. Let's do the image with tag say 3.1. okay, so on my Docker host, I'll go back and I will type the docker pull Elgalu Selenium colon 3.1. the image is being downloaded. We can also search all the publicly available images on Docker Hub using the docker search command on the Docker host itself. So for that, let's do command, let's say for Fedora. So let's clean this a bit, and then docker search Fedora. Now let's scroll up a little bit. Now it will search images and return. So things like repository names, then the image descriptions, stars, official, automated, right? So now stars are the measure of the popularity of a particular image. Secondly, the official means an image is managed by the upstream developers. For example, the Fedora image is managed by Fedora team and all of that thing. So you can see it here, it's right. And automated OK means an image built by the Docker Hub's automated build process. Hello everyone. In this nugget, we will learn about the Docker file and building images from it. A Docker file is a text document that contains a series of instructions paired with arguments. Let's take a look at the sample Docker file which I have created on our test machine. So vi Docker file. The instructions are basically commands you would normally execute manually in order to build a Docker image. The format for each instruction, for example from, should be the command name in uppercase and be followed by an argument from Ubuntu colon 18.10, right? So something like that. Now Docker can build images automatically by reading the instructions from a Docker file. Instructions in the Docker file are processed from the top down, so you should order them accordingly. Each instruction adds a new layer to the image and then commits the image. When a container is spun from the image, changes made by each instruction in the image are available in the container. This is kind of obvious as well, since the container is running instance of the image. The next instruction in the file is executed and the process repeats until all the instructions have been executed. If for some reason Docker file stops abruptly in the build stage, you will be left with an image you can use. So this will have all the commands executed till the point the failure occurred. We can run the instance of this image and do a manual check of the failing steps. This is highly useful for the debugging purpose. Now we will run the command to create an image from the Docker file I have on my test deployment. The docker build command builds an image from a Docker file, and the context, the build context is a set of files at either local path or an URL. The path is a directory on your local file system, whereas the URL is a Git repository location. A context is processed recursively, so a path includes any subdirectories and the URLs include the repository and its submodules. The build is run by the Docker daemon, not by the CLI. The first thing a build process does is send the entire context recursively to the daemon. As the best practice, we should add only the files needed for building the Docker file in the build context. Let's execute the Docker file on our test setup now. So let's go back here. So I have a directory test1. Okay. Now under which a Docker file is kept. Now this directory is our build context. Docker will upload the build context as well as any files and directories contained in it to our Docker daemon when the build is run. In our case, it will copy the index.html to the Docker daemon. The Docker file use the Ubuntu 18.10 as the base image. Okay, so it will put the label maintainer inside the image. It will run the update on the image and then install nginx. It will copy the cursor custom provided index.html to default the location of nginx. We also provide container command nginx -g in the quotes daemon off to start nginx, and the container will keep running until this process is running. An entry point allows you to configure a container that will run as an executable. And then it will expose port 80, that is as we know already, instruct the container to open port 80 for the communication. Now I will run the docker build command and we will give it the image as Pushpam Saxena. So let's do that. Docker build -t Pushpam Saxena /nginx, and the version is 1.0. The image name indicates that it will be a user level repository. The build context will be the current directory, hence a dot. Let's run the command. Okay, so it will take a couple of seconds here. Okay. So repairing, so all of those steps once it is done. Okay. The Docker command shows information about the steps that it has undertaken. Once the command has completed, we will run the docker image ls, let's see, to see the image on the system. There we see, that's our image created just now, and size is around 158 MB. We want to check if the image actually does its job. For that, we will spin a container from the image. So docker run itd rm rm-p 800:80. Okay, so that is an external and internal port, and then we will have the pushpam saxena nginx :1.0. We will run the docker ps to see if the container is running successfully. So let's go ahead. Docker ps and container is running. We will access it on the browser now. The external IP address is of this setup is 35.231.235.139, and it is listening on the 800 port. Okay, there is our HTML is displayed, which means the image was created correctly and the container spun from it. Okay, the command to show different layers and their size is docker history. It shows the history of an image. So now let's go back to our host and let's run it on the image we just created from the Docker file. So docker image history followed by a tag. Each instruction in the Docker file is converted into a separate layer. Okay, so we ran the label. So these are the various layers that we had in our Docker file. We ran the label instruction. We provided the update, installed nginx, copied this file, provided the entry point, and exposed the port. Now these layers are basically from the base image, as we see here, which can be seen from the created days as well, that information. In such cases, the image ID is provided only for the last layer, because before that we don't have any information regarding it.